Good morning. Morning, Buick. Morning, Trix. Madam Soda. Yeah. What? Continue. Yeah, continue. Tangents to circles. So you know from circle geometry that a tangent touches a circle at one point. Maybe the only one that counts. And that a secant is a chord that sticks out on either end of the circle. Okay, so with circle geometry in analytical, we now need to find the equation of the tangent to the circle. So how that relates to circle geometry is that the radius and the tangent are perpendicular. So if you can work out the gradient of the radius and work out the negative reciprocal, you can multiply the gradient of the tangent, that will equal -1. So radius perpendicular to tangent in Euclidean geometry is or translates to gradients being perpendicular in analytical geometry. Okay, so let's look at example 6. They're different things. First, we're going to show that a line is a tangent to the circle. So show that the straight line y equals -x minus 4 is a tangent to that circle. So the first thing we need is to find, again, the center of the circle. So that's the most important. So what's the center of the circle, Vivek? Center of the circle is 1 and -1. That's what? 1 and -1. And okay, so it even gives us a hint here. It says, how does one show that something's the center to the circle? Remember, a tangent to a circle touches it at one point, so it'll be necessary to show the group two graphs intersect one thing only. How do we show two graphs intersect? Intersect. No. This is a straight line intersecting with a circle. So when they're equal to each other. So can we substitute or solve simultaneously? We're going to substitute that into y's place. I don't know if the center is useful here. Let's check. Okay, so we're going to have x minus 1 all squared, and then y is minus x minus 4 plus 1 all squared. Okay, so here we get okay, so now we're going to get x minus 1 all squared, and here we're going to get -x, and minus 1 and 4 is -3 all squared equals 8. Okay. Foil that out. Remember, we're trying to solve for x and y. So here we're going to get x squared. Remember, when you square a binomial, you get 3 terms. 6x plus 9 minus 8 is 9. Okay, so we get 2x squared minus 2x and 6x is plus 4x, and 1 and 9 is 10 minus 8 is positive 2. Is not. Okay, if we want to factorize that trinomial, the first thing we can do is just divide and begin by 2. And then when we factorize that, we get 2 brackets that are the same. So x plus 1 all squared is 0. So how many points of intersection are there? X is -1. There's only one answer. Okay, so now if there's only one answer, it means that the straight line and the circle intersect at one point, which means the straight line is tangential to the circle. So we say, since Since the two graphs intersect at 1 point only, y equals negative x is tangent. Okay, so actually with this one, we didn't need the center of the circle. It had nothing to do with it. Okay, we just needed to show that the two graphs intersect at 1 point only. That makes it a tan.
The entity with negative one also counts as a vector answer.
Oh, it does. It's just, you're just showing it's tangential. So you're just showing there's 1 point of contact.
So if show that it's tangential and there's 1 point of contact, or if it's negative.
What? No, hang on. This has nothing to do with the gradients. This is solving simultaneously and getting one solution. If I got two solutions, okay, so if I got one solution, it means the straight line and the circle intersect at 1 point where x is -1 something. Okay, if I got two solutions, there it means that the straight line is intersecting the circle at 2 points. Okay.
Oh no, the metaphor is supposed to make it.
Yeah, so it's got nothing to do with it. We're getting these.
Okay.
Okay. All right.
Where's the y which is negative x minus 4?
You were given that as a straight line.
So where did you use that?
Yeah, so they're saying show that the straight line is the tangent to the circle. So we are making the two equations equal to each other, showing that because there's only 1 point of contact, the picture looks like this,
Yeah.
as opposed to 2 points of contact.
Mm.
Okay, so therefore, because there's only 1 point of contact, this straight line is a tangent to the circle. Because there's only 1 point of contact. I substituted
Yeah, I know.
this into y's place.
Oh, I see.
Okay, so it's like I'm solving simultaneously, essentially, yeah. So I substituted minus x minus 4 into y's place, solved for x, got only one answer for x, meaning that the graph is a tangent because it only touches the circle at 1 point. Okay. Next, now we're going to find the equation of the tangent to the circle. So this is where the gradients come in. Okay. So find the equation of the tangent to the circle. X squared minus 6x plus y squared plus 2y is not at 4. So I want the equation of this straight line. Okay. Where does this center 3, -1 come from? Yeah. How can I find the center of the circle? Yeah, they told it to us, but how am I supposed to find it?
X minus 2. 3. This square thing.
The square thing. Okay, you did it so well last lesson. Go.
X minus 3. Y
Minus 3 all squared.
yes.
Plus
1
y plus 1 all squared is
0. 9 plus 9.
yes. So we get x minus 3 all squared. Y plus 1 all squared is 10. So what's my center?
-3. No, 3 and -1.
Right. And what's my radius? It's 3 in this case.
10.
10. Okay, so now I've got the center and I'm trying to get the equation of this tangent. So Zizi, what do we know about the radius and the tangent?
They're perpendicular.
They're perpendicular. So what should I work out? Remember, when you want a equation of a straight line, you need a gradient and a point. Okay, so we need the gradient of this line. How am I going to get? We've got the point. I need a gradient. How are we going to get the gradient? Okay, first, we need to work out
This side of
We need to work out, we need a gradient. Where's the gradient going to come from? Okay, I need to work out this gradient first. Okay, so the gradient of the radius. How do you work out the gradient of the radius? Oh, you know, y2 minus 1.
Yeah.
So?
Y2 minus.
Okay, so what is it? What are the values?
Oh. So if I'm going to make y2 2.
Okay,
So 2 plus 1
okay.
over what's it called? 3 minus.
If you started here,
Oh, 4 minus 3.
oh, excuse me, thank you. 4 minus 3, yeah. So we get 3.
3.
Okay, so that's the gradient of the radius. Now, what would the gradient of the tangent be? Remember, they're perpendicular. The radius and the tangent are perpendicular. The negative reciprocal. So it's easy. If this one is 3, what's the gradient of the tangent?
Negative.
Negative?
3.
Reciprocal. Reciprocal. Numerator becomes denominator, denominator.
Negative 1 over 3.
Oh, there you go. Okay, negative a third. Okay, so now, Prim, we've got the gradient, we've got the point. What are we going to do with that information? And we're trying to find the equation of a tangent. What kind of line is a tangent? A straight line. So what formula are we going to use? Y minus?
Oh, 1.
M into x minus x1. What's going to go into x1 and y1? Why would we put 3 negative 1 in? Okay, it's got nothing to do with lying on this line. Okay, so we're going to put y minus 2 is negative a third into x minus 4. How were your Seora talks yesterday?
It was kind of useless. No, but it kind of made me feel better about university. I guess that's I feel like they should have rather gone more in depth on like 2 speakers than like vaguely on like 6.
Okay, so give that feedback.
I'm good now.
It's fine. I am on the set committee. I was like, okay. So what do you think?
Like for example, some speakers I completely disagree. They had very different on the same thing. So if we let's say I had 2 people so the whole thing of like having more difficult to have like an array of perspectives, especially since like they have like different views, people and stuff. Them say that there's something that is like give as much information as possible. But like, what did they disagree on? Like, what did they disagree on? They should have both saying no, but they don't like skip. But they should stay within the 6 months. Yeah, like I don't think yeah.
You don't think I'm good?
No, I think having multiple people is good. Better. At least I don't know why it's this. The same thing.
Okay. So look at the different types of questions we've dealt with here. So we've dealt with how to showing that a line is a tangent to a circle. The next type was finding the equation of a tangent to a given circle. This one is now finding the equation of the circle when you've got a tangent. Okay, so different types of questions.
Okay.
No, that's the products are equal to number 1.
Okay. So now this type of question, equation of the circle with a given tangent. Okay, so we've got the line. y plus 2x is 11 is a tangent to the circle. We've got the center and we've got this point Q, but we don't know it. Okay. Determine the equation of the radius PQ. Equation of the radius. Okay, so Felice, how do we start? Okay, so we always need a gradient and a point. How are we going to get the gradient of this radius?
Is it by finding the gradient of the straight line of the tangent?
Okay, so what is the gradient of the tangent? We can only find the equation of the gradient if it's in standard form. That's not in standard form.
Yeah, if I get into
Okay, and the gradient is the coefficient of x. So the gradient is -2 of the tangent. So what's the gradient of the radius? Gradient of the radius is, sorry? Okay, so you've got a gradient. Do you have a point on the radius?
Yeah.
Okay, we don't have this one, but we've got the center, we've got the P. Okay, so the point is P, 1, -1. So how are we going to work out the equation?
I plus 1.
X and so it's 1 plus 1 is half into x.
Minus 1 half.
Half x. So that's the equation of our radius. Okay, so now we've got to work out the equation of the circle. To work out the equation of a circle, we need a center and we need a radius. Okay, so what have we got? So we've got the center. Okay, so can we work out the radius? Well, oh, no, not yet. We don't. It would be great if we had that point, but we don't. So we would need something to substitute in. So we know so far what we've got. Just give me the equation of what we've got so far for the circle.
And we've got
So substitute it into the A and the B.
is it minus 1
Minus 1 squared.
squared plus y plus squared equals r.
Okay, so that's what we've got so far. In order to solve for r squared, we would need to substitute a point. Do we have a point that lies on the circle that we can substitute in? Not yet. So how can I get this point, Zippel? You've got the equation of the tangent. You've got the equation of the radius. How do we find a point of intersection of two graphs? And we make them equal to each other. Yes. Okay. So what are the two equations? This is the two equations. We've got y equals 2x plus 11. That's the equation of the tangent, and we've just worked out the equation of the radius. So what are we going to do with those two?
Make
them equal to each other. Okay. And I get minus 2x plus 11 equals a half x minus 3/2. Okay, so how do I solve this?
all the x's to minus
Before that, can I get rid of the, I don't like these denominators. Multiply everything by 2 to get rid of the denominator. So we get?
so we get negative
X minus. Left and X is on the left. Everybody else on the right. So we get negative 5x, it's negative 25, so x is 5. And how do we get y? Does it matter which one? No. Preferably the one without the fractions. Okay. So Q has got coordinates 5, 1. So Kiara, now that we've got Q is 5, 1, how was that going to help us?
See, now we have the point of like the intersection.
Remember, we're trying to get the equation of the circle. So we've got a bit of it, and we said, well, we would really like a point to substitute
So
in.
now we just figure out the radius.
Can't
Use the distance.
Hey, why don't you just substitute that in? It's so much easier. Okay, so you're going to put this. Where's the 5 going to go in?
Yes.
And the 1?
The line.
So we get 5 minus 1 whole squared. It's 5 minus 1. So that's 16 and 4. But then the final equation of your circle, Kiara, would be?
Well, x minus 1 squared is 5 plus 1 squared. It's 20.
Careful. It's r equals r squared. So it equals 20. What is the radius? Root of 20. So don't make that mistake. Okay, this is r squared here. Must go into the equation. Does my charging thing have a little heart there?
Oh, because you've got your life on your life, your battery.
I'm better say wrong.
So there's a what's it? A lightning bolt,
Charging.
and then why is there a heart?
Your battery saver.
Why am I saying better?
Because that's what she chose.
I wish I saved battery. I told you, I picked my laptop in, I got home and the laptop's dead.
So next is false under this.
It really is. Okay. All right. Are we good? Questions? Okay. Next type of tangent question is what were you asked? Determine the equation of the circle. That's perfectly fine. You can leave it like that.
You don't have to.
We don't have time.
Okay.
Okay. Yeah.
Is this our last week?
Is this out?
Last week.
For prelims?
Yeah.
Yeah. So
we're not going to have something else.
well, I haven't done the last geometry theorem, which I really got.
Just a theory.
It's a theorem on a practice. So
Isn't it Sam?
yeah, quick from right analytics.
Why don't you just do it? Like, so that one's very challenging.
Quick from right analytics. Mr. Wilkin is looking at this. He's got a video on it. Might just post the video and then you guys can watch it.
Oh, but you know what? You know like Zach, that's like low for child abuse, like
Oh,
that's a lot.
Okay, next time. Find the length of a tangent line segment. Okay, so we've got all the 4 types. Prove it's a tangent to a circle, find the equation of the tangent, find the equation of the circle given a tangent, and now find the length of a tangent line segment. What is a tangent line segment? This is a tangent line segment. In other words, it has a start and an end. A tangent line segment ends at the point of contact over there. Okay, like that. So the length of that. What kind of triangle are you seeing?
Right angle.
Therefore,
Pythagoras is the
Okay. Right. So a tangent line segment is drawn from point T 2, 4 to the point A, xy, which we don't know, on the circle. With equation x minus 1 all squared plus y plus 3 all squared is 14. Determine the length of the tangent line segment TA. Okay. So you know that the tangent is perpendicular to the radius. Okay. And if I join them up, I get a right angle triangle. And Zizi has just told us we can use Python. You're not asked to solve for A. You are asked to solve for the length of this line. Okay. We might need to solve for A actually.
You could just solve TM at the end. Oh. Yeah. Oh, you like your length of.
Okay, so are we able to work out the length of this line using this formula? Right, Danny, go. So TM.
The distance of TM is 2 minus 1 squared
Yeah.
plus 4 plus 3 squared.
What is this?
Yeah, it's like. I don't know, there's something about.
Root of pi. Okay. All right, so we've got the length of the hypotenuse. Next. It would be great if we could find the length of this line. What is this line here, this green one? No, what is it? What's the name of that line? The radius. Okay. So what's the length of the radius? I don't know.
Not root.
Yeah, but that's also squared. You just hold.
Yes, it's being done.
Same thing. You want, what's it? 5 root 2 root 5.
Let's face it.
Same thing. Okay. Right. Nyla, what is MA? Okay. MA is, are you listening? MA is the radius. How are we going to work out the length of the radius when we don't have this point?
Using that X.
The form.
Yeah, it's already there. Tell us.
So it's the square root of 14.
What?
Because the formula said that the radius squared is 15.
Remember, equation of the circle, this is r squared. So my radius is the root of 14. So now you've got this and you've got this. So can we work out TA?
Yeah.
Right, go. Kristen using Pythagoras.
The root of 5 root 2 20 squared.
Okay, so tell me, yeah, so TA squared is 5 root 2
Okay,
squared.
minus
Why are you minusing?
you could not work it out.
Okay, and you must say Pythag. You must have a reason there that. Right. So we get 6. So I get 36. So what is TA? 6. Done. All right. Do not spend time with these ones trying to work out that point. Unnecessarily.
It's not as
Okay. And we are done. So can we put for that table vertex quickly?
Yes.
Okay. Those are some useful exercises to work through. Memos will be on Teams. Okay.
You did it. New record.
I did.
Yeah.
2.5 days. How many days?
3. Last time you said 3 days. So
It's
no,
not-
it's 2.5.
2.5, sure. And we even practiced some examples. Okay, world record. What am I looking for?
The first one I popped up. When did you watch the music from my English and my yesterday? Yeah, what? Yeah, and she always say, "Oh no, not enough." Yeah. And it said in message on the yeah, you just I know what I forget. No, there's you start so what are we getting? It's fine. It's who I'm going to message. Oh, okay. Anybody else? And if everybody goes by to take up in what is average? What is normal? I was so confused. Talking to his he's trying to listen next to it. I feel like you mean after they take into their faces. And they woke up. I was totally not that. And then I take it off. 65%. I was too focused. Yeah, in that. She's actually the outlet. He said, that's even I think I'm be. That makes sense. Yeah.
Carol, once I have done this, you will be able to pick up any past 22 and do the whole thing from beginning to end without giving anything out. Okay, that's why it's important that we just put from right and roots so that you are able to start doing past paper twos because we need to practice paper twos. Can we do a whole paper ones yet?
No.
But we don't have done finance, we haven't done counting principles.
Counting.
Okay, so just to recap, the theorems in matric geometry were the proportion theorem, where you have to state the parallel lines, and the similar triangles theorem. The last one is perfect from right angle vertex, and it works like this.
How did she just put it down? The float oh, in the study, I took about elephants running upstairs. So much noise from the math departments, and that's actually crazy. Yeah. Oh, especially when you're in the library, bro. That's crazy.
Let's just say that the classroom above the library is that business classroom, not my classroom. Below that is the archives room and the service room. So when you're hearing noise from the library, it's of nothing to do with me. Yes, if you look very right. Because I do the like jumping up and down. Yeah, I'm shouting as well. Okay, right angle vertex. So what happens here? Got a right angle triangle. Okay, so this is specifically to a right angle triangle. From the right angle vertex, from B, I am going to drop a perpendicular. Hence, perpendicular from right angle vertex. Doesn't look very perpendicular, sorry. Oh no. What did I just do? What did we? Oh, Chris, how do I do that? Oh, there is. Oh,
What is the whole life?
oh, let me about a mouse wrong.
Just on your. No, I know what it's called. We plan tables. I would not things.
So ordinarily I just use the whiteboard, but because I'm getting to the lesson so that you can see it, I have to use this thing.
At all.
I'm working on this thing, which is how to get a blank document.
Yeah.
Yeah, here's a question. I'm listening.
What
We're not putting anything at the moment. I'm just trying to tell you what it says.
What is the thing that we use in the offices that we're proving, like when they go prove that it's why, or like prove that.
Yeah, okay, can you give me a sec? I'll get this. Promise I'll tell you what to do. Just give me a second. Okay,
Stop.
No.
Stop. She's trying to make you feel better, bro. She's trying to. Yeah, me either. And then she's like, hey, you actually
All right, so from the right angle, I'm dropping a perpendicular onto the hypotenuse. No,
Oh, that's a really thing.
no, this is what it says.
Okay.
It says if you have, this is like the easiest theorems. Okay, you'll get it in 2 seconds if you just listen to me. So what it says is that if you drop perpendicular from the right angle onto the hypotenuse, you actually create 3, 1, little, 2, medium, and the big one, 3 similar triangles. You don't have to prove they are similar. You can just say they are similar. So we would say triangle A, D, B is similar to triangle. So that's the small one. ADB, Paige, give it to me. Give me the medium triangle in the right order. If I go ADB, I must go.
Oh, but I go C. But I need to know first grade compliment.
Not alphabetical, in the order that it is equal. So if I start at A and I go to the right angle and then I go to B, I'm going to start at C to the right angle and then the last one.
I'm going to restart. B. Yeah, after the B, do you see? Because B is the short.
It doesn't equal this.
I don't know if it's. I can get
Right, let's do this. Let's do it this way. Let's take the big triangle. I'm going to go A, B, C. Right. A, B, C is similar to triangle. It's one little one. If I start at A, I'm going to start at A because A is common. Okay, A. Then I go to the right angle. So I must go to the right angle. And then I end off at B. And that is similar to triangle.
CBC.
CDB.
C is the common one. So C, you must end with C. This is the right angle.
Oh,
BDC. So BDC. Okay. And the reason is from right angles. So what I'm trying to say is you don't have to prove they are similar. You can say they are similar. And because of perp from right angle vertex.
This theorem thingies.
I said I was going to show you the breakdown. So I'll show you.
She nothing was right. I don't please see it's
Actually done what I need to actually tell you. So the important part of this is that there are these corollaries that happen from this. And the corollaries work as follows.
I'm just teasing, but it's
So
I'm thinking as no corollaries. I think that's how I relate to the next day. It's not such a good conversation. Not really, because it's not like we can no, it just wasn't you on so much.
yeah,
So jump a perpendicular from the right angle
to create 3 right angle triangles that are similar to each other. To create 3 right angle triangles that are similar to each other.
One. That's long. Yes, this is long. But it smells.
No, but just smelling.
It's essential one.
Okay, what are they going to help us do? Concentrate, remember.
What does lavender promote?
Lavender.
Oh, leave in here.
It's very one episode 20. Did you see the things? Jeremiah, that's don't stand like this is my house. I'm 18. His face so he's so good looking. Oh, minus one bit. The only funny there I don't have is I just don't like every scene. Exact kilometers. Yeah. That's a change. I know what I want. He's got these tears exactly times in it. I just think it would be very good. So funny. They know that my famous franchise. It's free. He's
Using sides in proportion and the first two triangles, these two. Right, write the sides in proportion for me, Jimmy.
AD over AD equals AC over AB. No,
Yeah,
yes, equals BC over DB.
are we all okay with that?
Yeah.
I am going to focus on these two sides in proportion. Cross multiply and say that AB squared is AC times AD.
Why those two?
I'll show you.
I forgot to refill it.
Okay. Page, using these two triangles, write the sides in proportion for me.
DB over DC was AB over C.
Okay,
I just love the small of apricots.
it smells so good.
It's so actually
All right, I want you to focus on these two page cross multiply.
AD
And you see what I'm trying to get to me? I'm trying to get the squares. Okay. And now, Kristen, doing that one and that one, write the sides in proportion for me.
You ready for the last?
And I want the last two, yes?
Now
The light blue.
Yeah.
Yeah. So I'm trying to write sides in proportions of the different possibilities of the triangles.
Alright.
So the two pink ones is this sides in proportion. The two green ones is this sides in proportion. And then those two are those sides in proportion. Is that fine?
Can you do it?
Yeah.
It's fine. We have this complete.
Okay. Can we just look back at our original triangle? Trix, I need you just to concentrate until the end of the lesson, and then you can talk about whatever the hell you want. Okay.
That's not it. So 80 squared is 20 UG squared is equal to AC squared.
All right. Look at the patterns that this thing makes. Okay. AB squared, so the short side, that squared, is AC times AD. Okay. BD squared, sorry, let's do BC squared. BC squared, this one here, equals AC times DC. Okay. And BD squared, this one, equals that times that. Those are the corollaries that are formed. Okay. I don't know. So it's just the patterns that, so these are the corollaries. So you can say BC squared without proving it. You can say BC squared is AC times DC heard from right angle vertex. And AB squared is AD times AC heard from right angle vertex. And BD is AD times DC heard from right angle vertex. You don't have to, you can write the signs of proportion and show it, but you can just jump there. All right, now I need you all to watch. This is like the most important thing. I want you to take AB squared from here and BC squared from here and add them. Okay, so I'm taking AB squared plus BC squared. All right, Nyla, what would that equal?
AC times 80 plus 80 DC.
Okay with that? So I'm taking AB squared and BC squared and I'm adding them up. So as a result, I'm going to say AC times AD plus AC times DC. Okay, we good? Right. Kiara, factorize this. What's common?
Common is AC.
Right, so I'm going to take out AC and I'm left with AD plus DC plus DC. Okay, are we right with that? Back to the picture. What is AD plus DC? Danny, what is AD plus DC?
AC.
AC. Are we okay with that? So AD and DC is actually AC. So now I've got AC times AC, which is AC squared. So here I've got AB squared plus BC squared is AC squared. What have I just proved? AB squared plus BC squared equals AC squared. What have I just proved?
I know.
Not nice. That's the proof. I like it.
Seriously, madam.
I understand you. Thanks, we're going to have to know that.
No, I get you to prove the theorem by notes. So I know that Python is that squared plus that squared is that squared. So that's why I said, yeah, from some of the triangles, choose those two and it works out. Okay, wait. See how good that is for last.
Sorry, wait, but it also is the fact that I only this whole thing.
Yeah. It's been a lot.
It's crazy.
Oh, yeah. Let me get some.
But it makes so much sense. But if writing this exam, like,
So now also when you go and watch Mr. Borkman's video, hopefully it'll make a bit more sense. Breakdown. Okay, there you go. So, if one, right. Algebra and equations and inequalities is about 25 marks, give or take 3 each way. So it could be 28 or 22. So basically between 22 and 28. Patterns and sequences, so sequences and series, 25 marks, give or take 3. Finance is 15 marks, give or take 3. Functions and graphs, 35 marks, give or take 3. Calculus, 35 marks, and probability, 15 marks. So that's the breakdown for paper 1. Okay. Huge emphasis, as you can see, on functions, graphs, and calculus. Yeah.
So if you haven't done finance way, you can save those 15 marks.
Yeah, good question.
Oh, wow.
Okay.
So
Okay, paper 2, don't spot. Paper 2, bookwork. What's bookwork?
exercises?
Theorems, proofs. Okay, 6 marks. Stats is 20. Analytical is 40. Trig is 20. No, they've changed this.
Okay.
They've changed this. Sorry, it's the other way around. The trig and yeah, trig and geometry. Yeah.
I guess landing. I think it's pretty jobs get my stone.
Okay, all right. So that's the breakdown. But what I actually want to do is just an example of a perp from right angle vertex with you so that you know what to expect.
She's scared.
It did.
For me though. AD plus DC turn into AC. I'm not pushing.
Yeah.
So, slowly. Oh, because it's literally A. Oh. Two. Where does the 2 go? Yes, it's AC, but where did you get the 2 from? It's really supposed to. Yeah, it's not well. Yeah. You're watching. If they were seeing a lady from like that, they can do and it starts take on this it starts like 0 like and then it's no, you increase all of the but you have to try to say focus on something on the last year it's people's and I've been nice and I got nice this session of the document with me and she made this next I just blind you know things to know the business yeah how to be kept and maybe there is a challenge thing. Yeah, and just
Yeah. Yeah. Well, it's linking my protractors and then you get them back. But I'm okay. So we've got intersection on side. BAC equals ACD is 90 degrees, and AD and BC intersect at E. You've also got that they're perpendicular. Prove that AB times AE equals AC times, oh, okay. AB times AE equals AC times BE. So they look horrendous, okay? But this one is just from right angle vertex. Why? I just put
She always is like the right.
see a triangle.
Yeah.
And previously a perpendicular dropped onto the hypotenuse from the right angle.
Yes.
That's why I've put from right.
That's from A down.
Okay. And how many of those are there actually? So you see that there are two triangles that do that.
HE and CT.
See a butterfly. All right. So
I see angle and same sort of segment.
I don't see circles. There's no angles in the same thing. Okay. Right. Write the triangles. Who wants to write the triangles in the right proportion? Okay, goes easy. The triangle.
Triangle A. No, B.
Start with the big one.
Yeah, triangle BAC.
BAC. Right. Is similar to the triangle.
Triangle. And
If you did A, B, C. So now do B.
B, 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 A,
Which way?
B,
You start with B, then you went to the right angle.
Yeah.
So
A, B, E,
E, A. All right. And what's my reason for that?
A.
Curve from right angle vertex. Okay, so now what I'm saying is you don't have to prove them similar. You can just say they're similar. Curve from right angle vertex. Why do I not need or bother with the next triangle?
You can look
Look at the sides you need. AB, AB, AE, AE, AC, taken care of, and BE, taken care of. So you're not going to waste your time to do the third one as well. We don't need it. Okay, so now, right, what are we going to do with this?
We're gonna make them in the fraction.
Right, write the sides in proportion. So we get
B A over B E A B C over B.
reason?
Well,
Similar triangles. So I can say the sides in proportion because the triangles are similar. Okay, so now who did we want? AB, AE,
and AC.
AC, and B. So we're going to choose those two. And what are we going to do with them? Eh? How are we going to get them to look like what I want? The two multiplying.
Oh,
Can we cross multiply? All right, so we're going to get E times AE. Doesn't matter. I'm trying to get it to look like A, B, A, E, A, C. So it doesn't matter if you go A, C, or C, A. All right. Are we good with that one?
Yes.
How are we going to get AC squared is BC times CE. Which ones do we have to use now? Look at what you have to prove. AC squared. So AC squared means AC, AC, BC, and CE. So which two triangles would you write? The
A, O, A, B, C.
the big one and
AC.
and that one. And you can say they are similar. Curve from right angle vertex, right sides in proportion, cross multiply to get this. Okay, when we want EC times AE and another EC times DE. So now which triangles have we moved into? Those ones.
AC and
Curve from right angle vertex. Okay. So what you good luck for all your exams, especially maths. I hope the half I hope that half year was productive for you and that you use it wisely to study for the prelims. I am available if you need a quiz. Keep sending me a message on Teams. Will you be doing it? No, I'm home. I will also be running some assistance class that's not next week. Before you write your maths exam, I'll set out some time. I'll look at your timetable. I'll see after an exam, and I'll set up the time. Is that good?
Yes,
Right. Many have gone before you, as we saw yesterday, and survived, perfectly fine, balanced, wonderful individual woman. Okay, so love you, bye. Say it.